Hi everyone, I'm Khanh from the TensorFlow team, and today I'd like to show you how to train a TensorFlow Lite model that can recognize custom images using your own dataset. And then my colleague Hoi will show you how to integrate the model into an Android app using the new ML model binding plugin in Android Studio. In this example, we'll build an app that can recognize 5 different types of flowers: daisy, rose, sunflower, and so on. Now, let's get started. We'll start with training our model in Google Colab. Google Colab is an environment that allows you to use CPU for free to quickly train your machine learning model. By using Colab, you don't need to install any software to your computer, you only need to use your web browser. You can go to this Colab notebook from this link. This is also included in the video description. Let's start by installing TensorFlow Lite Model Maker to Colab. Model Maker is a tool that allows easy training TensorFlow Lite models with no machine learning expertise required. Now the installation has finished. Let's import the required Python package. Let's download our training images from TensorFlow to our Colab machine. You can also download the training data from this URL to your computer to explore the training dataset. You will find that it contains images of 5 different types of flowers organized into each folder. So for daisy, we have several hundreds of images. Dandelion, rose, and so on. And if you have training images that you want to use, you can also upload them to Colab. Just go to the Files tab right here, click on the Upload button, and then you can upload your images. Next, we load our images into Model Maker. Here you can see that I split the dataset into train data and test data. The number 0.9 here means that we'll use 90% of our data for training the model, and the remaining 10% of the data to test its accuracy. I'll explain more about that later in this video. Now, the loading process has completed. Here we have 3,670 images in 5 categories: daisy, dandelion, roses, sunflowers, and tulips. Now we have our training dataset. Let's train our TensorFlow Lite model with the flower dataset. To train faster, make sure that you have enabled GPU in your Colab. Go to Runtime, change runtime type, and make sure that GPU is already selected. You can see that here I use only the train data, which is the 90% portion of our dataset that I loaded earlier. You can see that the model is now being trained, and the accuracy is improving. Now, after about 90 seconds of training, I have a model with 93% accuracy, which is quite good. You will probably see your accuracy number a little bit different from my accuracy number, because before training, the model is initialized with random weight values. So your initial value is very likely to be different to my initial value, which led to a slight difference in the final accuracy. And next, let's evaluate our model. You can see here that I use the test data, which is the remaining 10% of our dataset that I left out earlier. The reason why I did that was to keep some data that the model didn't see during training, so that we can test if the model can generalize well to new data that it has never seen before. Our test accuracy is about 92%, which is a little bit lower than our training accuracy but still pretty good. And finally, let's export our TensorFlow Lite model to integrate it into our Android app. You can see that the export process has finished, and now I have the TensorFlow Lite model in my Colab. Let's download the model to our local computer. And then I'll share the model with Hoi, my Android developer friend.
Thanks, Khanh. I'm Hoi from the Android team. Today, I'll walk you through the steps required to integrate the TFLite model that Khanh has just built into an Android app. The first step is to set up. Go to developer.android.com/studio/preview and select Download 4.1 Beta 1 as your option. You have the option to keep several versions of Android Studio installed at the same time. If that's what you want to do, please scroll down on this page and refer to the documentation saying Run Alongside Stable and click on Install Both to find out more. Once you have Android Studio Beta installed, go to the URL link in the video description down below to download the Colab's Android Studio project. It contains the basic Camera X functionalities, which we will use to feed the model. Just like any good cooking show, I've already downloaded the Android Studio Beta, installed it, and also downloaded the Android Studio project that we're going to work on. So let's take a look. So this is Android Studio version 4.1 Beta 1. Let's open up the project and see what we have. So let me just find it, click open. And here, Android Studio is opening the project itself. It's indexing all the files, and this might take a while depending on what you have set up on your machine. So it looks like everything is fine. Okay, as you can see, we have two modules here in this project, Start and Finish. So under Start is the projects that we're going to work on, and Finish is basically the finished project. So if you ever get stuck in this particular Colab, go to Finish and you'll be able to see what the code should be. So we'll be working with Start throughout this project. And one of the things that you can do at the very beginning of this project is to just run the Start project. So just click here to run it. So Gradle is building and it's now installing. And this is what you should see on your screen, which is a preview of what the camera sees. And at the bottom, you have three labels that are printed right next to some random numbers that are fake labels. And that's the start of our Colab. Okay, let's stop that and go back. And one of the ways to really easily navigate through this Colab is by viewing all the to-dos. So if you click on View, Tools window, To-Do, you'll see a list of different items within the projects of what we needed to do. And one of the ways to easily see that which ones are under the Start project is go here, Group By, and select by module. And here, all the to-do items are grouped by Finish and Start. Under Start, these are the actual places where we expect to insert code. The first to-do is actually nothing to do with code, but about importing an actual model. So let's do that. Let's import the model that Khanh have created. Okay, so the easiest thing to do to import the model that Khanh have just produced are the new tooling that you get with Android Studio 4.1. To start, right-click on the module where you want to put the particular TFLite model. Select New, select Other, and here we have the TensorFlow Lite model. Click on that, and then select the model location. Open it up. I've got it under here, under Download. So one thing you have noticed is that I've actually changed the name of the model that I've downloaded. So can't name it model.tflite. If you import it without changing the name, then the classes that are generated for you to use that model will be model. And model is an awfully common name. So in order to reduce confusion, always change the name of your model into something that is a little bit more meaningful. And you will see that further down in this particular screencast. So now select that model, click Open. Here we have the path. And what else have we got here? So the other things that this import module will do is not just copying the TFLite model, but actually insert the necessary settings to use the model. So there are two things here. One is to enable a new build feature that is in Android Studio 4.1, the ML model binding. In addition, we have some Gradle import and dependencies that we will need in order to use the ML model binding. So they're here, and they will be inserted automatically into your build.gradle file. So no more messing around with the setting file. Another thing that it has is if you want to use the GPU acceleration and through the TensorFlow Lite GPU delegate, you'll need to do this. We'll do that as later on in this particular screencast. So don't worry about it for the time being. So let's click Finish. So after you have imported the model, this is the first thing that will greet you in the new Android Studio 4.1. You can see from a high level, what it does. So for example, the input is an image of float, and then the output is 5 labels. And in this case, those are the 5 labels of flowers that Khan have trained. And if you go slightly down here, you will also see the sample code of how to actually use the new ML binding functionality. So you initialize an instance, create an image from either the camera or a bitmap, and then you process the output and you get the probability as a list. So here we have an image analyzer class where we are using the CameraX functionality, and for each frame that the CameraX gets, it will basically feed it into the analyze method here. So before we can use that, we'll need to initiate the model itself. So let's do that. Let's create a private instance of the flower model that we have just imported, and call it flower model. And the way to initialize it is like this. So just call it flower model dot new instance, and then feeding in the context. Here we go. So you'll notice that here we're basically using the same name as the TFLite model itself. So name your TFLite model carefully before you import, so that you will have a much better time in terms of finding out which model you should be using, and basically give it an intuitive name. So now that we have got an instance of the model, what do we do with each of the frame? The first thing to do is to convert the image into a format that we can process, namely the TensorFlow Lite or the tensor image format. So let's create a variable, call it TFImage, and create an instance of tensor image from bitmap. So if you have done this before with TensorFlow Interpreter, you have noticed that previously you might need to convert your image into byte array directly. Here, you don't actually need to do any of that. The input can be bitmap. And in this case, we have image proxy. So in this case, we need to convert that into a bitmap before feeding it in. So I've created a helper method here to say to bitmap, feeding in an image proxy. And this is all you need to do. If instead of using a camera as an input and you want to load up an image that is already on the phone, you can feed that bitmap directly here. Next, we're going to feed this particular image into the model for processing. So we will create a output object. So outputs, and we'll utilize the flower model that we have initialized before and process it. Process the TF image. And what we can get after we process the image is basically a list of category objects, which include both the label as well as the probability of the output or detection. So select that. And then next, what we want to do is to sort it so that the highest probability result is at the top. And then we want to limit it to, let's say, the top 3 items. And how do we do that? So there is this really helpful Kotlin feature that will allow you to sort through the list by specifying the attribute that you want to sort on. So what we do is I'll go dot apply. And here I'm going to say sort descending, because what we want to do is to sort the list so that the highest probability is at the top and the lowest probability is at the end of the list. So let's do that. And here we need to specify which field we want to sort by. So I will type in it dot. So here you can see the 2 fields. Of course, we're not going to sort by label, but instead we're going to sort by the score, which is in this case is the probability. So here we go. We have got the list of the different categories together with the probability, and we have now, with this one step, sorted it by the probability itself. The next thing that I'm going to do is I'm going to cut the list down in size so that it only displays the top 3 results. And the way to do that is to use another column feature .tick, and we can say the maximum display results. So this is a constant that I've defined as being 3. You can absolutely change that to whatever you want. In this case, it may not be helping a lot because the list itself is only 5 items. We're only training a model with 5 different types of flowers. But you could imagine that if you have a model that have 100 different categories, or maybe even 1,000, or maybe even tens of thousands or hundreds of thousands, this could really help you cut down on the number of results that then get passed on and processed. So please do take time to kind of consider this so you can cut down the amount of processing that you need to do. So after this, what I need to do is to convert those category results into data objects that my particular application will understand. So I've created a data class called recognition with a label and probability. So I just need to convert the results that I have. In this case, it's the 3 highest probable flowers that we have into those recognition objects. So let's do that. So it's for output in outputs. And I'm going to go items. So this is the list of items that we're going to return back to the UI. So items.add recognition output.label and then output.score. And here we go. One last thing before we can run the app is to take out this section, which I previously used to generate basically fake result, placeholder results, so that you can see the app running. So let's comment that. On the Mac is command and then /key to comment those particular blocks out. So here we go. We have our app. Let's see it running. As you can see, basically when you look at the sunflower, then the sunflower probability increases, and it's working as we expect. So one last thing I'm going to do before I sign off is to show you how you could use the GPU accelerator. So to do that, the first thing we need to do is to go back to the build.gradle file, and under here, so under the to-do, we can see that, hey, we need to add the optional GPU delegate. So in the previous color import dialog, you can just tick a box and get it. But in this case, because we didn't tick that box, we will need to manually perform this step. So super easy. Just type in implementation and is org.tensorflow :tensorflow TensorFlow -Lite-GPU 2.2.0, and let's press sync. Yay, okay, it looks like it's done it. So this step basically imported the TensorFlow Lite GPU into your project. And the next thing that we're going to do is to use it. So go to to-do 6. Here we need to create an options object for the model itself and say, hey, we really want to use the GPU accelerator. So to do that, create a private variable and call it options. And this time is we're using this model class. So under the TensorFlow support library, you need to choose this one, org.tensorflow.lite.support.model. So that's the one that we want. And then under that, there's options, and there's a builder for that option. First thing you could do is to say set device. You can also see that there's another option, set the number of threads. So set device is the option to use different types of accelerator. So in this case, we're going to use a GPU. You can also choose an API if you want. So set device, and then we go model dot device dot, in this case, GPU. And last but not least, we need to build. But just before that, I just want to highlight this other option that we have, set the number of threads. So if instead you want to use different CPU threads to run your model, you can also select this one and then type in as an integer how many threads you want to spin up, and that's all you need to do. In this case, we're going to leave it with the GPU and build this object. So at the moment, this option is not used, and the way to use it is by just doing comma and say options. So there you have it. Just 2 lines or 1 line of code and then a method change, and now you can use the GPU to accelerate the running of your model. So let's take a look. Fantastic. So the model is running again, but this time around, it has now got the GPU acceleration enabled. So to sum up, make your own model and running it on Android has never been easier. You can use the model maker that Khan has shown you to train the image classifier, and the Android Studio tooling I've demonstrated to put it to work on Android. Check out the video's description for more. See you next time.